Dear students, now we are going to see the course Signals and System. Under that, the topic is Analysis of Continuous Time Systems. On the study of continuous time systems analysis, the students can able to analyze the continuous time system using Fourier transform and Laplace transform. Impulse response of LTI system with and without memory. A convolution is given by y of t equal to integral minus infinity to infinity x of tau h of t minus tau into d tau. Convolution is commutative, so y of t equal to integral minus infinity to infinity h of tau x of t minus tau into d tau. A continuous time system is memoryless if the present output depends on present input. The above condition is true only for h of t equal to k into del of tau, and such a memory system has the form y of t equal to integral minus infinity to infinity h of tau x of t minus tau into d tau. That means y of t is equal to integral minus infinity to infinity x of t minus tau k into del of tau into d tau. K into x of t into convolution of del of t is equation 1. Here x of t convolution del of t is equal to x of t. So y of t equal to k into x of t. K is a constant. The system is memoryless or static if h of t equal to del of t. Then equation 2 is not satisfied if the system is dynamic system. Hence, the output is equal to the input. This system becomes an identity system. Invertibility of LTI system. Consider a continuous time LTI system with impulse response h of t. This system is invertible if it has an LTI inverse system. We know for an identity system, x of t convolution del of t equal to x of t, the impulse response of an inverse system should satisfy the condition h of t convolution of h1 of t equal to del of t. Causality for LTI continuous time system. A system is said to be causal. The output of the system must depend on the present and past input only, and the impulse response h of t is 0 for t less than 0. The convolution integral becomes y of t equal to integral infinity to t, that is minus infinity to t x of tau h of t minus tau into d tau, or y of t equal to integral 0 to infinity h of tau x of t minus tau into d tau. Stability of an LTI system. For an LTI system to be stable, the system's impulse response should be absolutely integrable. That means integral minus infinity to infinity h of tau into d tau value should be less than infinity. The Fourier method for analysis, that is frequency response of LTI system, is consider an LTI system y of t equal to x of t convolution of h of t. Then the Fourier transform analysis. First we have to apply the Fourier transform on both sides of the equation. So we are getting y of j omega equal to x of j omega into h of j omega. The convolution in time domain gives the multiplication in frequency domain. H of j omega is the frequency response of the system. So h of j omega is the ratio of y of j omega to x of j omega. The magnitude of the equation 1 is the magnitude of y of j omega equal to magnitude of x of j omega into magnitude of h of j omega. H of j omega is the gain of the system. The phase equation is given as the phase angle of y of j omega equal to the phase angle of x of j omega into phase angle of h of j omega. Here the phase angle of h of j omega is the phase shift of the system. Analysis and the characterization of LTI system using Laplace transform. The output of the system is given by y of t equal to x of t convolution of h of t. Taking the Laplace transform on both sides of the equation, we are getting y of s equal to x of s into h of s. X of s is the system function or the transfer function. S is equal to j omega. H of s is a frequency response of LTI system. Causality for causal LTI system, h of t is 0 for t less than 0. The ROC of causal system is right half plane. ROC for causal system with rational system is right half plane to right and rightmost pole. stability, an LTI system is stable if and only if the ROC of its system H of S include the j omega axis, that is the real part of S is 0. A causal system with rational system function is stable if and only if all the poles of H of S lies in the left half of S plane. Quiz question: which condition determine the causality of the LTI system in terms of its impulse response? Only if the value of impulse response is 0 for all the negative value of time. Thank you for watching.